Welcome, everyone. Thank you for joining us for today's webinar, Siting Portable Buildings, presented by Thomas Anderson. Thomas is a principal engineer in our structures department at our corporate office located in San Antonio, Texas. He has been involved in several full-scale test programs conducted at BakerRisk's Box Canyon test facility, in which portable buildings were subjected to vapor cloud explosion loadings. In addition, Thomas has co-authored published papers based on that testing, including a paper documenting the siting of a portable building for use at BakerRisk's test facility. He's also assisted clients with the detailed evaluation of portable buildings at process plants, including designing mitigation measures to increase the protection of building occupants. Today, Thomas will cover and provide answers to why there is a particular focus on portable buildings, what differences are there between portable buildings and fixed buildings, how do portable buildings respond to the impacts of potential process plant hazards, what guidelines are available to assist in the siting of portable buildings, and what options are available to improve the response of portable buildings to the impacts of potential process plant hazards and thereby improve the safety of building occupants. Now, I want to go over a few housekeeping items. Please type any questions into the Q&A box in the Zoom control panel, and our technical staff will respond to these questions. I want to thank Joshua Bruce Black and Jody Kostecki for being here with us today to answer those questions in the chat. Finally, at the close of our webinar, please provide feedback by responding to our survey. We're excited to get this presentation started, so without further ado, I will turn the time over to Thomas.
Thank you, Naomi. I appreciate it. Again, my name is Thomas Anderson. Thank you to Naomi for that introduction, and I'm going to be presenting on siting portable buildings. As just a brief introduction, I've been with BakerRisk almost 19 years of experience and licensed here in the state of Texas. I'm a civil structural engineer, and I'm happy to be here to present this to you today. So loosely, what we want to talk about today, we're going to talk about why is there a focus on portable buildings, what guidelines are available to help one site portable buildings, and then also, what is a portable building? How do portable buildings respond to process plant hazards? And then what options are available to improve the safety of building occupants? So those in mind, let's look at the first. So why focus on portable buildings? Well, it really comes down to the Texas City incident in 2005. It was a large explosion. 15 people were killed in and around trailers, portable building trailers. 180 people were injured, and approximately $1.5 billion in losses were incurred. The occupied portable buildings were near a process unit during a turnaround. And so the Chemical Safety Board, the CSB, recommended to the American Petroleum Institute, or the API, to issue new recommendations for portable buildings. Or really for the siting of portable buildings. And specifically, there was CSB recommendation 2005 4I-TXR2. And in response to that recommendation, API issued the Recommended Practice, or RP, document 753 in 2007. And so here's an image of the aftermath of the explosion from the CSB report. And I'm going to use my pointer. But you can see that there were trailers both located here, sort of in the foreground, and then also in the background there. And you can see that essentially these trailers are all destroyed, and these here are destroyed as well. So this is the incident that prompted this particular focus on portable buildings. And I've taken an excerpt from the specific recommendation and wanted to read those to you so that you have a context for why the API 753 document is as specific as it is. So the CSB recommended that first, the practice document that they issue has to protect occupants from accident hazards such as heat, blast, overpressure, and projectiles. And then establishes minimum safe distances for trailers and similar temporary structures away from hazardous areas of process plants, and then evaluates the siting of trailers under a separate methodology from permanent structures, since trailers are more susceptible to damage, are more readily located, and likely do not need to be placed near hazardous areas. And so those three items at the end are kind of the important part that sets portable buildings apart from fixed buildings, is that they may be more susceptible to damage, can be readily located, and likely do not need to be near the hazardous area. So what guidelines are available for use? Well, again, the American Petroleum Institute recommended practice documents provide recommendations to industry on how to evaluate and mitigate hazards. And as far as buildings go, there are really three primary ones. API RP 752, and that's the management of hazards associated with location of process plant permanent buildings. And then the focus of today's discussion is API RP 753, which is the management of hazards associated with location of process plant portable buildings. And then there's a third document, which is API RP 756, which is the management of hazards associated with the location of process plant tents. Now, all three of these documents were updated in 2024, and the recommendations address explosion, fire, and toxic hazards. And BakerRisk previously presented an in-depth webinar about the specific updates to these RP documents, and that was enhancing safety, understanding updates to API RP 752, 753, and 756. And we have the QR code there that can be scanned that would link you to that presentation. So which document do you use? And this is a excerpt from API RP 753 Annex B, but all three RP documents have this table in it. But this table provides example coverage for the various building and tent types within the document. So depending on what type of building you have, and you can see the building descriptions here on the left, it tells you which document you need to go to. And our focus here is on 753 today because that's specific to portable buildings. And so that includes lightwood trailers intended for temporary placement, lightwood trailers for perpetual use in a specific fixed location, blast-resistant modules intended for temporary placement, other modular buildings intended for temporary placement, and then any portable building with fabric panels. So those are the types of buildings that are covered in API 753. And so API has a set of guiding principles, and I wanted to reiterate those here. So first we have the principle to locate personnel away from process areas, consistent with safe and effective operations. Minimize the use of buildings and tents in close proximity to process areas. Manage the occupancy of buildings and tents in close proximity to process areas, especially during periods of planned abnormal operation with increased risk, including but not limited to unit startup, testing, or plant shutdown operations. Design, construct, modify, and maintain buildings to protect occupants from the hazards created by explosion, fire, and toxic material release, and then manage the use of buildings and tents as an integral part of the design, construction, maintenance, operation, and emergency response of the building. So you can see that these are the guiding principles that are in the document and then would then guide the decisions or the recommendations that are made within the document. And with respect to building hazards, API further lists mitigations arranged in a hierarchy. beginning with the most effective as follows. So as we go from left to right, it's most effective on the left to least effective on the right. So the first would be to eliminate either the occupancy or the hazard. So can you remove the people from being subject to that hazard? Can you reduce occupancy or the severity of the hazard? So can you reduce the number of people that are subjected to the hazard? And then also, as you know, you can remove and reduce the number of people, or you can work on the hazard side to try and remove or reduce the hazard itself. Third is to increase the distance between the occupants and the hazards. Fourth is to increase the resistance of the building to the hazards. So if you cannot increase the distance, can you strengthen the building? And then finally, can you administratively manage who is actually in that location? So then coming to what is a portable building. And so I think we all may have an idea of what a portable building is, but API RP 753 has a maybe a very basic description of what a portable building is. And they simply say, any building that is designed to be movable, regardless of the length of time it is kept at a specific location. So a portable building is any building that's designed to be movable, which I suppose makes sense. But then maybe that eliminates or adds buildings that you thought maybe were not subject to this guideline. But I took a few pictures here just for discussion purposes. And on the left, we have a ISO shipping container that's been converted into an office space. And one could maybe argue that it doesn't appear to be there temporarily, since they've built a ramp that goes up to it, and it's even connected to power directly. So, but because the building itself is designed to be movable, it's considered a portable building. And in the center here, we have a wood-framed trailer or portable building type. So that's maybe what we would think of more when we think of portable buildings in this context. And on the right, maybe a slightly controversial one, but this one is a analyzer house in a facility that's in a fixed permanent location. It's got its own slab foundation, but it's skid mounted, and it was designed to be constructed in some place and moved to this location. So the question would be, is that a portable building in this context? And really, I put this picture here just to make one think about it, not necessarily to make a judgment on that. But I would say that personally, it could be included because it was intended to be movable, even though it's not movable in its location. And so that you can look in that table in Annex B, and you can find, particularly if such a building is occupied, find a category that fits that building. So before I go into the hazard discussion, I wanted to just present to you BakerRisk testing, research, and development, because a lot of the videos that I'm going to show you here, or all of the videos that I'm going to show you here, comes from our test ranges. And so I just wanted to briefly mention those. So BakerRisk has the Wilfred E. Baker test facility, and that site provides various test apparatus for client needs, including multiple shock tubes, jet fire and dispersion testing, and you'll see a video on the jet fire in this presentation. We have high speed and high pressure projectile and terminal ballistic research test pad, underwater high pressure release test pad, a drop test apparatus, severe load static test apparatus, and a vapor cloud explosion test pad. And you can see it's a 160-acre facility about 30 miles southeast of San Antonio. And really the spirit behind this test range is that we will try to test whatever you want us to test. So if you have an idea and you need some custom testing done in this space, we will do that. The Box Canyon test facility, you'll see some videos on that. And particularly in this facility, we have a large-scale vapor cloud explosion test site. We have the deflagration load generator test site, which is the image shown on the right. And that's a test rig that can produce a full-size directed vapor cloud explosion. So as you can see in this image, we're testing a pre-engineered metal building with a blast load. We also recently introduced the capability for high explosive testing at this facility, and then we can also do our jet fire and other miscellaneous testing at this site. And this is a 2,300 acre facility about 100 miles west of San Antonio. And then a lot of the videos that you're also going to see comes out of BakerRisk's joint industry research program called the Explosion Research Cooperative. And that's a industry-sponsored testing program. It's been going for over 25 years. And the goal is to improve knowledge in the process safety space. And specifically, how do you predict hazards and how do you protect people from those hazards? And that's really the main goal behind it. So out of these sites and out of this program, we're going to see videos today. So then let's jump right into it. How do portable buildings respond to process plant hazards? And here's just a video of a lightwood trailer in front of our DLG rig. And so just for everyone to see, I'll play that again. And you can see that, you know, we're able to generate loads with our DLG in all sort of range of blast load pressures and impulses. And you can see that a portable building can be overwhelmed significantly by explosion loading. Here's a high speed of that test as well. And so you can see here that the response of this trailer in this test is you would say very similar to what was seen at the Texas City incident. So moving on to what I'd like to show you today is go through a series of hazard demonstration videos. We'll talk about structural damage, which you just saw in that video of the testing of the lightwood trailer. We'll talk about non-structural debris, global buildings translation, and then thermal resistance. We'll also touch on other considerations such as toxic mitigation and then vendor products, and specifically turnkey portable buildings. But the idea that I want you to keep in your mind is that a hazard, we want to relate hazards to what happens to the people. And what happens to the people is termed occupant vulnerability. So if there's a hazard, it impacts the portable building. There are people inside that portable building, and what happens to the building is translated to what happens to people in the building. And that the outcome of that is potential fatalities. And so when we talk about impacts on buildings, we're really trying to get to what's the impact on the person due to that hazard. So I want you to keep that in mind, that it's not just purely a assessment of what's happening to the building. You're really trying to say what happens to the person in the building. And that's where we come to facility sightings in general. So for portable buildings, we're really focused on the fact that there can be hazards to people before there's a primary failure or collapse of the structure. And that's really what I'm going to get into today. So first we want to talk about non-structural hazards. So what is a non-structural hazard? So this is a hazard related to architectural, mechanical, or decorative items, which are either anchored to or sitting adjacent to interior surfaces of a portable building roof or exterior wall. So the blast response of non-structural items is that the structural members, so the structure of the building is going to move, particularly in the case of a blast load applied to that portable building, those surfaces move. So anything that's attached to those surfaces will also be accelerated and move. And if the anchorage of those items are not or is not sufficient, then those non-structural items can become debris and get thrown into the space where people are. And so that is when I'm talking about non-structural items in this context, that's what I'm talking about. It's anything that's attached or adjacent to exterior surfaces of a building, of a portable building that will move and could be thrown. And so this is an item that's recognized by the recommended practice document. And you can see here on the right an image of a drop ceiling, and then on the image on the right, you can see how that drop ceiling has fallen, the lights have fallen. And so that's an example of non-structural debris. And in the testing that BakerRisk has done, this debris can reach hazardous velocities and even create fatalities at lower damage levels within the building. And I'll show you some videos of that. And so here's a test that BakerRisk ran on a lightwood trailer through the Explosion Research Cooperative. And you can see that this is the items along the blast-loaded wall. And I'll play the video, and you can focus on what happens to the items that are along the wall. And so I'll play that again, and in particular focus on the cabinet and then the velocity at which that cabinet gets thrown from the wall. So that's an example of non-structural debris that results from a blast-loaded structure, but the structure itself has not collapsed. Here's another example that's been done through BakerRisk internal research on semi-trailers, and these are often used as temporary office spaces or tool checkout trailers, that kind of thing. You can see maybe the response from the outside doesn't look like much. But now we look at the inside, and you can see that anything that was up against the wall broke. And so this is the non-structural debris that may cause a hazard that we're talking about. Another example here, this is from the Explosion Research Cooperative of an ISO container. I apologize. And that's the response from the outside. Again, you wouldn't necessarily say that the structure is anywhere near to failure, but there is significant movement. And so let's look at what the inside response is. And I'll play that again and then focus on where the person is seated and wall-mounted items. They get thrown fairly violently. And so the point that I'm trying to make is that even though the structure itself may not be damaged to the point of failure. There are additional hazards that apply to portable buildings, but also apply to fixed buildings associated with non-structural items. So in addition to non-structural items and structural components response, sliding can cause accelerations, and that's what we saw with that ISO shipping container video. Debris can be generated even if the debris is anchored to or spaced off the exterior wall due to overall sliding of the building. And so adequate anchoring of modular buildings to the foundation will mitigate that sliding hazard. And so again, it's being aware of additional items that can cause hazards to occupants of a portable building. Now we'll change focus to look at a jet fire impingement on a portable building. And we'll look at, this is at first a video of the interior, and then we'll show a video of the exterior. And so this is a direct fire impingement on a portable building. And so in this case in particular, once the window failed, the fire was able to get into the building, and then there's really no escaping the hazard for anybody who may be in that portable building. Here's another study. The previous one was internal research. This one was a explosion research cooperative testing. Again, in this case, it was a steel modular building that was intentionally insulated to see if it could resist a jet fire impingement. And so the fire was impinged upon the structure to the point where the steel was glowing red hot. And so, unfortunately, though, the interior also heated up, even though it was insulated. So the steel studs, the interior was finished out with steel studs and 4-inch thick fiberglass insulation. The direct jet fire impingement was from a 1/4-inch saturated propane release. The insulation, the backside of the insulation reached 500 degrees Celsius or 930 degrees Fahrenheit within 5 minutes of the start of the test. And the air temperature inside reached 60 degrees Celsius or 140 degrees Fahrenheit within 10 minutes. And there was also a lot of off-gassing, meaning that that temperature increase, anything that was inside the building started to off-gas due to the temperature. And so you also got a very sort of toxic environment inside that was not survivable. And then I'll show you this video as well. But once the building was opened after the test and oxygen was introduced, or air was introduced to the building actually ignited on the inside. And here's a video of that. So the door was opened after the test, and it just ignited on the inside. So it's just an indication of these additional hazards that one may not necessarily think of, because you say, okay, well, the building's intentionally insulated to resist a certain temperature. But that's not the only thing that needs to happen. It's really how do the items inside the building respond to that temperature gradient and increase in temperature, and then what's the air quality as temperature increases and off-gassing happens. So it's something that's really maybe not something you think about, but something that one ought to think about if you're intentionally trying to do something like this. Now, for toxic considerations, we evaluate evacuation options. So personal protective equipment, escape paths, etc., as as your sort of primary mechanism. If you're to keep people safe from a toxic hazard, but if you choose to shelter in place, you have to determine and communicate the strategy to building occupants. And so BakerRisk, again, there's a QR code here provided to a BakerRisk shelter in place document that people can follow. It's a best practice document, but it provides these 5 items to follow. So number 1, provide a timely and reliable detection of toxic gases. And that's really inside the space that you're sheltering. Provide timely, reliable isolation of ventilation systems to avoid ingression of toxic gases. So that's in an attempt to stop drawing in toxic air from outside into the building. You want to be able to isolate that pathway. And then you establish a leak-tight shelter-in-place volume to minimize infiltration. So that could be a room within a building that you've designated as your shelter-in-place, and you've made it, intentionally made it to be a spot where people can go. And then a very big item is to train personnel and provide instructions to ensure that sheltering activities are performed properly. And also through the training, it's to get buy-in and confidence in what you're telling people to do. So you want people to be confident that if they follow the steps, that the outcome will be favorable for them. And then always provide an effective fallback and evacuation plan. And you need that communication with people outside of the shelter to people inside the shelter, so you can communicate when a evacuation is the best way to go. So what options are available to improve the safety of building occupants? And so if we go through this, what I want to show you here is a BakerRisk internal research study that we did on lightwood trailers and how we could strengthen them. And again, I have provided a QR code here in the presentation that goes to the GCPS paper that we wrote on this particular test program. But in this case, this is a lightwood trailer with an external hardening. And then we were able to increase the capacity of the structure by over a factor of 2 by applying this external upgrade. And again, this is a situation where maybe you have a leased trailer and you cannot make modifications to the structure itself, and you cannot move the trailer or the people, and you need to provide that protection. And so this is what BakerRisk has developed to strengthen a trailer in place without having to modify its structure. And then on the inside, what we also did was we looked at conventionally anchored internal items. So again, we're talking about that non-structural debris. And so these are just items that are like a cabinet that's hung as you would normally hang a cabinet, and workspaces that are just pushed up against the wall. I'll play that again. So the blast load, the front face of the building facing the blast load's on the left and the back is on the right. So you can see, even with that external strengthening of the building, and from the previous video, we saw that the overall movement of the structure, you'd say, was very small. But even that slight movement caused non-structural items to fall. And so this is looking at in the same test, just in the next office down, we then intentionally anchored the same items to the wall, meaning that we are using anchors here that are more robust than your typical hanging of or conventional hanging of items. And so you can see there's a contrast in how these respond. is very simple to do, but you have to be thinking about it. And that's really what the purpose of what I'm trying to communicate today is. There are simple solutions to some of these hazards. And then you can also get vendor products. So intentionally designed portable buildings to resist the hazards. And so here's a side-by-side comparison of a fortress modular building and a steel-framed blast-resistant modular building. And so the reason why we show that video is just to say that when you are getting if you're trying to get a blast resistant or vendor product or any intentionally designed product that you're trying to get to protect your people, it's really important to know exactly what you're getting and that what you're getting is responding in the way that you are intending it to respond, if that makes sense. So it's very important for people to know the response of what you're purchasing or what you're leasing or whatever the case may be. And so the primary focus is that you should request documentation for all performance ratings. So the vendor product should do what you want it to do, and it should address the different aspects of hazards to personnel. So in sort of summary of the portable building hazards that we discussed, there's the structural damage from blast loading, and this is typically the primary driver of explosion vulnerability to occupants. And hopefully we've shown that not all buildings are created equal. And so it's important to know what the performance of the particular building is that you're using. We've introduced you to non-structural debris. So this is potential vulnerability at low damage levels, but we've also shown that that's really easy to limit those hazards. But number one is awareness. You have to be aware of how you set up your workspaces, what you're putting up against the walls, and the fact that even if the damage isn't to the point of causing structural damage, that structure is still moving. And so that can throw your non-structural debris. Sliding hazards are real and exist. And so that means that a building can be pushed and displaced globally by a blast hazard. And so your anchorage of that is your best practice. Thermal considerations. So we've sort of shown that it may be difficult to be able to shelter in place in a portable building that's exposed to fire impingement. And so in that, typically evacuation is the way to go there. And what we tell our clients in this particular context is that you always want to provide a exit pathway that goes away from your risk, from your hazard. So if you know that your fire hazards are coming from a particular direction, in your portable building, can those portable buildings be orientated such that the exits are away from that hazard? So that gives people a clear pathway to evacuate once they recognize that a hazard is present. For toxic considerations, again, evacuation with PPE, and then shelter in place requires a clear communicated and trained strategy, and we've gone through that. And then in terms of vendor products, and these are turnkey, again, products that are designed to resist specific hazards, you have to know and verify what the performance of that vendor product is. Don't just take someone's word for it. Verify that what they're providing you is actually performing the way you want it to perform. And so that concludes the presentation portion today, and we'll go ahead and take some time for your questions. So thank you very much for your attention.
Oh, thank you. I'm going to go ahead and ask some questions that did come up during the presentation. And then just as a reminder to our attendees, if you haven't already done so, be sure you're typing those questions into the Q&A box there in the control panel. So a lot of great information, great examples, Thomas. So one of the questions that came up are wood trailers the weakest portable building?
Oh, thanks, Naomi. No, not necessarily. The focus is on lightwood trailers primarily because of the Texas City incident. Mm-hmm. And that's really what put the focus on lightwood trailers. But it's important to recognize that preferences and even the construction of portable buildings can change over time. And so API 753 acknowledges that there may be portable buildings that are inferior in performance in comparison to lightwood trailers. And so it's really important that one scrutinizes the particular portable building that you're using and verify its performance. Because simply saying that a lightwood trailer is the weakest portable building is not true.
Excellent. And they might think that just, there was an example of one of those wood trailers. So,
right.
Yeah, it can be a little bit scary, but thank you for clarifying that. For question 2, in your opinion, what's the most important consideration when siting portable buildings? Would have any insight on that?
Yeah. I would say that if we and maybe this is maybe an easy way out, but I would say that if we take direction from the API RP documents guiding principles, I think one should really ask, are the personnel really needed to be placed in that area? And so that to me is the most important consideration is, do they really need to be there? And if the answer is yes, then you really need to manage who goes there in that particular location.
No, appreciate that. We've only covered a few of the questions that were asked, and I'm going to go ahead and ask one more before we conclude the webinar. What about doors and windows? You talked a lot about the, actual structure, but what about doors and windows? Can you elaborate on that?
Yeah, thanks. I didn't get into the blast performance of doors and windows in this case. We did show the video of the sort of performance against the jet fire. But I think for portable buildings in general, if you can avoid having windows, that's probably the preferable way to go, because it does add an additional or can potentially add an additional hazard. But I think that, and then with doors, we touched on orienting the structure such that doors are away from the hazard. And I know that's not always possible, but even in the testing that we did, you saw that we had doors on the backside of the structure, and that was intentional, so that we're not blocking the escape path of the people within that structure. But I think, as with any other structure, the doors and windows must perform adequately relative to the anticipated hazards. So, yeah.
Awesome. No, appreciate that. And like you said, I mean, sometimes you never know where you're going to need to exit from. You may have
Right.
planned for one side and yeah, so appreciate that. Just want to say thank you to everyone for joining us today. Thomas, great job. To Jody and Joshua, thank you for answering some other questions that did come up live in the chat. And if there are any other questions, be sure to put those into the Q&A box, and our presenter will answer these questions. We'll get it packaged together and sent out and post his responses via email, newsletter. We'll post that on LinkedIn and also to our BakerRisk website, which will also have the link to the recorded webinar from today, slides from this presentation, and then those answered questions. So thank you again for your time, everyone, and be sure to fill out the survey. Have a great day. Thank you,
Thank you.
Thomas.
Yep. Next.